This is lesson 8.5 for Precal. It's due 4/13 by 11 a.m. on 4/13 because I have them opening and closing like school hours, like you're in class. So this lesson is about vectors and comparing vectors to see if they're equivalent, finding magnitude of vectors, that kind of stuff. So the first thing is you're going to have two different vectors like GE, and you have an arrow, which means you're going from G to E, and then JB, and this one is actually, nope, actually, I don't even want to call it that. We're going to call it AB. Okay, so I've got vector GE and I've got vector AB, and then you're given coordinates. Like G is -4 to 5, and E is -4, 2. Then A is, let's see, A is 1, 2, and B is 1, -1. Okay, so when we're going in, when we're looking at the arrow, that means we're going from G to E. We're going from A to B. We want to know if these are equivalent vectors. If I could spell equivalent correctly, it would be amazing. Meaning they have to have the same magnitude, which is the distance. So the same magnitude, which again is just distance. So we're going to be using distance formula with these. And then they also have to be going in the same direction. So they both have to be going right, or both left, or both up, both down, something like that. So same distance and same direction. So that's what you have to check. You're asked to graph them first, and you'll choose a graph because it's multiple choice. So G is -4, 5. So G would be left 4, up 5. So there's G. And then E is -4, 2. So -4 up 2 is that right there. So I'm going from G to E, going from G to E like that. So that's the way that vector is going. Then A is 1, right 1, up 2. That's A. And then B is right 1, down 1. So there's B, again going in that direction. So they have the same direction. So we've got them graphed correctly. They have the same direction. So that part's checked off. So they've got the same direction. They're both going down. Okay. Now you just need to find the distance. You need to find the distance of GE and AB. So you use the distance formula. So my distance formula, remember, is x2 minus x1 all squared plus y2 minus y1 all squared. And then you just plug into distance formula. You've had it since Algebra 1, doing distance formula. So I'm going to find it for GE. GE, my x's would be -4 minus -4 all squared, plus 5 minus 2 all squared, because those are my points, -4, 5, and -4, 2. So this would be 0 squared plus 3 squared, so it'd be 9. So it'd be the square root of 9, which is 3. Okay. So then for AB, my x's are 1 minus 1 all squared plus 2 minus -1 all squared. So that's 0 squared plus 3 squared, which again would give me 9. So square root of 9 is 3. So these are considered equivalent. They have the same magnitude. Remember, these are magnitudes. They have the same magnitude, same distance, and they have the same direction. So on these problems like this, you have 2 or 3 of them. You've got 3 different answers. The first one is yes, both vectors have a magnitude of whatever, and they have the same direction. Another one would be no, because the vectors are different, because the magnitudes are different. So if you find different magnitudes, so you're going to have to make sure you pick the correct answer out of A, B, and C. Okay, so here we have the same direction and the same magnitude. So it's yes, they both have the same magnitude and in the same direction. You could have a no because they have different magnitudes. You could have a no, they have the same magnitude, but they have a different direction. So make sure you choose correctly. The first thing you have to do is choose the graph, like I've shown you here. So you choose the graph, It's multiple choice. Find the magnitude, look at the direction, that kind of stuff to say if they're equivalent. So that's what you do on those. You've got 3 of those that are all like that. Actually, you've got 4 of those that are all like that. Sometimes you have a different magnitude. Sometimes you have a different direction. So just look. Look, if you have a graph, let me just show you one. Let me just show you one like this. So we've got GA and BH. So this is telling us the direction. This is telling us we're going from G to A and B to H. So G is our starting point, A is our ending point, and the same with B and H. So let's see, my coordinates are G is -3, 5, A is 0, 2, then B is 3, 2, and H is 0, -1. Okay, so I'm going from G to A, from B to H. So first thing you're going to do is draw this. You're going to draw G is -3, 5. So here's G right there, -3, 5. A is 0, 2. So 0, 2 right there. So we're going from G to A. So there's that direction for that one. Then for B, it's 3, 2. So right 3 up 2. This is B. And then H is 0, -1. So 0, -1. So that's going from B to H. So these do not have the same direction. Not same direction. So they can't be equivalent. So these are not equivalent. Now the deal is you still have to find the magnitude because they're still going to ask you for the magnitude. But you're going to make sure you pick A, B, or C. You're going to make sure you pick the one that says they're not the same direction. You pick the graph first. Like I've shown you, pick the graph first. It's not the same direction. They're not equivalent because of that, but you do still have to find your magnitude. You still have to find the distance of those 2 vectors using the distance formula. So for GB, I would have the square root of 3 minus -3. I would not. That is not correct. Let me start that over because I'm doing GA, not GB. Doing GA. So GA, my x's would be 0 minus -3 all squared. My y's 2 minus 5 all squared. So it'd look like this. That's plugged into the distance formula. This would be 3 squared plus -3 squared. So that would be 9 plus 9, which is the square root of 18, which is 3 square roots of 2. Okay? So that's the distance for GA, or the magnitude for GA. Now we need to find it for BH. So I would do 0 minus 3 all squared plus -1 minus 2 all squared. Okay? 0 minus 3, -1 minus 2, using the B and the H. So that's -3 squared plus -3 squared. 9 plus 9, square root of 18, 3 square roots of 2. So they have the same magnitude but do not have the same direction. So they're still not equivalent. So you're going to have to choose the one that says, no, they're not equivalent. They have the same magnitude, 3 square roots of 2. And you're going to have to put that in the blank. They have 3 square roots of 2, but they're not the same direction. So just choose carefully. Read carefully and choose carefully. Okay, then we get to... let me put this up here again. Okay, then we get to where you have 2 forces. So we have 2 forces. We have one that's 33 newtons, and the other one is 45, and they act on an object at a right angle. So when that happens, you've got like 33 here and 45 here. 33 newtons, 45 newtons, they act on an object at a right angle. We want to find the magnitude, and we want to find the magnitude of the resultant. So this we'll call magnitude of resultant. You just want that distance. It's a right triangle. You're going to do a squared plus b squared equals c squared. Actually, there's a little shortcut to it that I'm going to show you. And then we want to find the angle it makes with the smaller force. So angle with the smaller force. Angle with small force. So my smaller force is 33. Why? Because it's smaller than 45. So to find the magnitude of the resultant, it's really just square root of x squared plus y squared. This can be x, this can be y. It's just the square root of both of them because you're finding the hypotenuse of a right triangle. So you just do square root of 45 squared plus 33 squared, and that gives you about 55.8, which is 56, because they're asking you to round to the nearest whole. Make sure you read correctly. Sometimes they want the nearest tenth, sometimes they want the nearest whole. Okay? Then you want the angle with the small force. The angle with the small force is up here. You want the angle the magnitude makes with the small force, or the magnitude that the resultant makes with the small force. So we want this angle right here. So it's always an inverse tangent. And it's an inverse tangent here of 45 over 33, because if my angle's up here, this is opposite, this is adjacent. So it's an inverse tangent. And then that gives you about 53.7, which is about 54. Okay, so that's the angle with the smaller. If they wanted the angle with the larger, you'd come down here. And if you wanted for larger force, it would be inverse tangent of 33 over 45, because you'd be down here at this angle and 33 would be opposite in 45. But it's always an inverse tangent. It's always an inverse tangent. Don't use what you find for the resultant. Use the two numbers you're given. Okay? So there's that. And then sometimes they will give you where you've got a vector that's 50, you've got another vector that's 36, and your angle is 90. So guys, this is the same as this problem. You've got two forces acting at 90-degree angles. So you're here. This is 50, this is 36. So this is your U, this is your V, because that's a V. And it's a 90 degrees. There's the 90 degrees. And we want, again, the magnitude of the resultant. So we want the magnitude of resultant. Resultant is just where you add them up. And we just need to find the magnitude. So again, it's a square root of 36. That's a 36 squared plus 50 squared, which gives you about 61.6 if you're asked to round it to the nearest tenth. Then we want the angle that the resultant makes with U. We want the angle that the resultant makes with U. So we want this angle down here, because here's my resultant, here's U, and I want the angle. So again, it's inverse tangent of 36 opposite over adjacent 50. That gives you about 35.8. You were asked to do it to the nearest degree, so about 36. So let's see what else. Okay, then you can have, they actually give you a triangle. It's a balloon, so you've got this triangle right here. This is a right angle. This is 13 feet per second. This is 4 feet per second. You want V, and you want this angle down here. So again, V is your magnitude. So to find that V, you're going to do the square root of 4 squared plus 13 squared, which gives you about 13.6 or 14. So that's your magnitude, that's your resultant. And then you want this angle down here. Again, it'll be an inverse tangent of opposite 13 over 4 adjacent, which gives you about 73 degrees. So that's how you do that one. Okay, then you're going to have problems that tell you you've got a wind with an easterly component. Easterly component of 12 kilometers per hour. Then you've got a southerly component of 14 kilometers per hour. We want the magnitude and direction of the wind. So we want magnitude and direction of wind. So we need to be careful here, because this is where we've got an easterly and southerly component. So we've got to remember, if we're talking about north, south, east, and west, north, south, east, west. My N looks like a W. Okay, north, south, east, west. Remember, this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270. That's how it changes when we're dealing with north, south, east, and west, okay? it says we've got an easterly component of 12. So I'm going this way 12 and a southerly component. So I'm down at 14. Okay. So what does that mean for us? It means we have to be careful and make sure that we actually find this whole angle, because we've got to go from north. Okay. So what's going to happen is we're going to find this little angle right here, and we're going to have to add 90 to it to get the correct direction, because we're directed this way. So I've got to make sure I have from 0 degrees, from true north, from due north, I've got to make sure I have the correct angle. Finding the magnitude is just the same. The magnitude, the distance, is going to be the square root of 14 squared plus 12 squared, which gives you about 18.4. Then that's the magnitude. Then to find the direction, again, you're still doing your inverse tangent. You're still doing inverse tangent because we want this small angle right here of 14 over 12. So inverse tangent of 14 over 12, which gives about 49. It gives about 49. So that means this angle right here is 49 degrees. So I want the whole angle. I want this whole angle right here. So that means I've got to take the 90 degrees right there and add to 49. Just to find the correct direction, it's 90 plus 49, which would be 139 degrees. So be very careful with that when you're working with north, south, east, and west. You know, here's the drawing of it. Those are the angles. And then make sure you find your correct direction. So it means you've got to make sure that you put these on there. The easterly and southerly, you know, make sure you put them on there correctly. Okay, then we have an airplane takes off at a speed. So we've got an airplane. Speed is, what is it, 235 miles per hour. That's the speed. And then we're at a direction of 19. Okay. So what we want is it says to resolve the vector. What that means is you want the horizontal component and you want the vertical component. Okay. Now what's nice about this is because our direction is between 0 and 90. So again, if we're thinking about an airplane, we're thinking about north, east here, south here, west here. So if my direction is 19, it's like I'm in the first quadrant. Okay, if my direction is 19, it's like I'm in here. It's like I'm between 0 and 90 degrees. So nothing weird happens is what I'm trying to get at. Nothing weird happens. So if we want the horizontal component, if I want the horizontal component, it's my x. It means you take the magnitude, which is here the speed, cosine of the angle of direction. Then if you want the vertical component, which is your y, you take the magnitude again, which is the speed, sine of the angle. So if we want our horizontal and vertical components, we want to resolve it and get the components, the horizontal and vertical components. So we're going to take the speed, which is 235, cosine 19, and we're going to take 235 sine 19, and that's going to give us the horizontal and vertical components. This is horizontal, this is vertical. So 235 cosine 19 for the horizontal gives you about 222. If you round it to the nearest, sorry, I ran over my S. And then the vertical component is 77 because it's 235 sine 19, which is 77. So that's how you find your horizontal and vertical components. Again, it's not really in the first quadrant. I shouldn't have said first quadrant, but it's in this first part where we don't have to do anything weird with the angle, okay? Because it's between 0 and 90, so we don't have to do anything weird with the angle, which is like what we see when we're talking about our quadrants 1, 2, 3, and 4, okay? So then we've got a 93-pound force. 93-pound force F, and it makes a 33-degree angle with the horizontal. Okay, so I've got a 93-pound force F that makes a 33-degree angle with the horizontal. 33-degree angle with the horizontal. And we want the horizontal and vertical components. So I want horizontal component H, which is your X, which is 93, that's your force, cosine 33. Then if you want the vertical component, the Y, it's 93 sine 33. So your vertical is always the cosine. Your horizontal is always the cosine, your vertical is all the sine, and I am giving you a shortcut on that. So on the cosine, it's about 78.00 pounds. That's what you label it. You're going to be asked what to label it, and since it's a 93-pound force, that's why we label it with pounds. And then 93 sine 33 is 50.65, so your vertical, and it is pounds again. Okay, so that's how you do when you've got a 93-pound force, it's making a 33 angle with the horizontal. To find those components, to find the horizontal and vertical components, that's what you do. Horizontal is always cosine, vertical is always sine. There's that one. Then they could actually draw the picture for you at times. So you could see something like this. This is an arrow, this is an arrow. This is 1233, and this is a 45-degree angle right here. So again, it's a 1233-pound pull. It's a 45-degree angle with the horizontal, but they've got this drawn for you. So we want the horizontal and vertical components. So I want my horizontal, which is X, which would be 1233 cosine 45. And then I want my vertical, which is Y, which is 1233 sine 45. And if you look at this triangle that's drawn, think about it. Opposite over hypotenuse. What is opposite over hypotenuse? Sine. That's why you will use sine. I've just done a shortcut for you. Then here, if I want X, well, it's adjacent over hypotenuse. Well, that's cosine. Okay, I've just shown shortcuts. And remember, the cosine and sine of 45 are the same. So these are actually going to be the same answers. 871.9 pounds and 871.9 pounds. Because the cosine and sine are the same, and 1233 is the same. So that's weird because it has a 45-degree angle, so they came out the same. That won't always happen unless it's a 45-degree angle. Okay, then let's see. We've got another airplane. And this airplane is flying in a direction of 313 degrees. And at 250 miles per hour. And we want the westerly and northerly components. Okay, we want the westerly and northerly components. So again, let me draw a picture. This is north, east, south, west. Okay, and we want the northerly and westerly components. So we want west, which is your horizontal, which would be your X. And we want the north, which would be your vertical. We want the northerly components. So we still want vertical and horizontal components, okay? West and north. So this is where we have to be careful because we know it's going west and north because that angle is 313. So if we think about our angle measures again on here, this is 90, that's 0, that's 90, this is 180, this is 270. So my angle is in here because it's 313 degrees. So I'm in this quadrant going 250 miles an hour, okay? So there's my magnitude, 250 miles an hour. That's my magnitude, and I want this and this, westerly and northerly, okay? Now, here's where we've got to be careful. We've got to make sure that we use the correct angle because we can't use 313 because 313 is this whole angle, and I'm looking at this triangle right here. So I just need this piece right there. That's what I need, is that piece right there. So what you're doing is you're going to find this piece by subtracting 313 from 270. Remember, we always subtract or add from our, it's like our x-axis, it's our horizontal axis. So you're going to do 313 minus 270 and get this angle in here, which would be 43. So that angle's 43, and that's how we find it, okay? Because we've got to have that small angle to find the right coordinates. Because again, I can't use 313 because 313 is not part of this right triangle. And I've got to talk about this right triangle right here to find the x and y of this right triangle right here that has an angle of 43, not 313. 313 just helps us find that 43, okay? And again, 313 minus 270 gives you that angle right there. Now we're ready to set up. So for west, for your horizontal, it's always the magnitude, which is 250, times the cosine of the angle, which we just figured out is 43. Then 250 sine 43, okay? So 250 cosine 43 gives you 183. That's your westerly, not degree. I keep putting degrees on everything. That's your westerly, okay? That's west. And then 170 is your north. So that's why you do that. And the thing you got to be careful with is this right here, finding that angle correctly. Okay, then another drawing you're going to be given, if I can draw it, I'll try to draw it. And you've got this load up here, and this drops down like that. Okay, actually that's not bad. This is 90. This distance right there is 90, not 90 degrees. Oh my goodness, quit putting degrees on everything. And this angle right here is 30 degrees. Now that one does have a degrees, okay? So what we're asked is for the magnitude perpendicular to the incline. We want the magnitude perpendicular to the incline. We want the magnitude parallel to the incline, okay? So again, giving you some shortcuts. The magnitude perpendicular to the incline is cosine. You're going to use cosine on perpendicular. You're going to use sine on parallel. So if you want perpendicular, it's cosine. If you want parallel, it's sine. And you take 90 cosine 30. And 90 cosine 30 is about 77.9 if you round it to the nearest tenth. Then you do 90 sine 30, which is about 52.9. So that's your perpendicular and that's your parallel. Perpendicular is always cosine, parallel is always sine. So sometimes they might ask you for just parallel. Sometimes I might ask you for parallel and perpendicular. So you could have one where we've got a block of ice. It weighs 90 pounds. And it rests on a 36-degree incline. And we want the force parallel. To keep it from sliding. So we want the force parallel to keep it from sliding. So again, if it's parallel, parallel is always your sine. So 90 sine 36. And that's all you have to find. You don't have to find perpendicular. Just 90 sine 36, which is about 52.9. Okay, and then the last one I'm going to show you, we're actually not going to use any of this vector stuff on it. We can actually use a lot of cosines, and it's going to make it easier. And let me draw it so you can see the drawing and know what I'm talking about. This is north, east, south, west. Then there's a lot going on. Okay, so you've got this right here. This is 150, and then this is dotted up here. This comes out, okay, and this is 150 as well. This comes back. Here is a missing angle that we're going to find. This is 700. This is 31 degrees. This reflex angle, which we actually don't have to use, is 329. Comes this way. Let me make sure I've got everything drawn on here. 150. I've got the missing angle. I've got the 31 degrees. That's 700. That's 150. Oh, and this is 62 degrees. Need that one. Okay, so on this one, it says a boat heads 31 degrees, propelled by a force 700 pounds. So that's that. A wind from 329, so this is your wind coming from 329, exerts a force of 150. So that's why this is coming down this way on the boat. Okay, that's why this is coming down this way. How large is the resultant force? So that's F. We want that right here because it's going to pull the boat. The boat starts out on this line, but this is going to pull. The wind is going to pull the boat down to this line. Okay? So again, we start here at 31 degrees at 700, but then because of the wind pulling this force, this 150, it's going to pull it down from this 700 to this right here, to this F. Okay? So we want that resultant force, that F, and then we want the direction of the boat. So if I want the direction of the boat, I want this whole direction from due north. Remember, we're always coming from due north. So we don't have to use vector stuff on this. Guys, we can use law of cosines because this is opposite 62 and I've got the sides around 62. So to find F, we're going to use law of cosines. It'd be the square root of 700 squared plus 150 squared minus 2 times 700 times 150 cosine 62. When you type that in your calculator, you get about 643.4 pounds. That's pounds of resistance on that. Okay? So there's your F. That's what F is. F is 643.4. Okay. Now we need to find angle theta. Guys, law of cosines again. I've got a triangle with all three sides. I can use law of cosines again. So to find theta, we're going to do inverse cosine of, now okay, here's theta. 150 is opposite, so that's the one that gets subtracted. So we're going to do 700 squared plus 643.4 squared minus 150 squared, all divided by 2 times 700 times 643.4. We're going to do the inverse cosine of that, and that's going to give us the angle measure. That's going to give us this angle measure, then we're going to add it to 31 because we have to have the whole degree measure. Because again, the boat starts here, but the wind pulls it down to this one. So now this is the magnitude, and then we need the correct direction. So we need to find this angle right here, again using law of cosines. And then that 31 degree angle. Again, remember, put this in your calculator very carefully. Make sure you put an extra set of parentheses around the numerator. And let me show you on the denominator. You know, put one set of parentheses with multiplication signs between those. So again, you did law of cosines. You should have been able to put it in your calculator correctly. This actually gives us about 11.9, which would be 12. So that means this angle right here is 12. So my complete direction, if I want the direction, because I've already got the magnitude, this is the magnitude, the direction, the correct direction, now it's the way it's directed now because of that wind pulling it down, is 31 plus 12, which would be 43. So now it's in the direction of 43. And again, we're still in this like it's the first quadrant, 0 to 90, so my angle is okay because my angle is 43, which is between 0 and 90. So I don't have to do anything weird on it, okay? So that's the way that one works. That is 8.5. Again, it's due 4/13. It's due Monday. Make sure you send me copies of your notes and your lesson, not just your notes, not just your lesson. You got to send me both.